Hello everyone and welcome to today's webinar, Enhancing Active Transportation and Demand Management with Advanced and Emerging Technologies and Data Resources. My name is Neelu Parvin-Ashtiani and I will help facilitate today's webinar. This webinar is sponsored by the Federal Highway Administration and hosted by the National Operations Center of Excellence, or NOCO. So if you don't know already, and as a reminder, at NOCO we offer resources to support the transportation system management and operations community. So on the screen right now you see a box called Useful Links. There you can find previous webinar recordings, case studies, and other services that we provide. So related to this topic, we have previous webinar recordings on the ATM implementation and operations guidance that was published back in 2017, and also several case studies on hard shoulder running and things like that. And I can share those links in the chat pod later with you. A few logistics for today's webinar. We are recording this webinar, and that recording along with the slides will be available for you to download through the NOCO's website. All of the attendees' phones are on listen-only mode by default, but please use the discussion question pod that you see on the screen right now to put in any comments or questions that you have during the webinar. At the end of the webinar, we have dedicated some time to go over your questions and read each of those questions out loud and help answer those questions with the moderator and the presenter. So that's all I had, and with that I would like to hand it over to our moderator for today, David Hale. David?
Okay, thank you very much, Neelu, and good afternoon, everyone. This is David Hale with Leidos. I'm the project manager for the ongoing FHWA project on enhancing ATDM with advanced and emerging technologies and data sources. I'll be moderating today's webinar that addresses this topic and presents a primer that was developed for this project. Now I'm going to switch ahead to slide number 2. On slide number 2, I'd like to introduce today's speakers. James Collier is a transportation specialist with the Federal Highway Administration Office of Operations. He's been with FHWA for over 15 years and has worked in offices in Arizona, Virginia, Washington, D.C., and Washington State. He has experience in traffic engineering, traffic analysis and modeling, intelligent transportation systems, and transportation systems management and operations. After James, we're going to hear from Daniel Lukasik. Dan is the principal investigator for FHWA's project on enhancing ATDM with advanced and emerging technologies and data sources. Dan is also co-chair of the TRB Active Traffic Management Subcommittee, and as lead of the Parsons ITS sector, he has overseen the deployment of over 40 ATDM projects and strategies. After Dan, we will hear from Joshi Ma. Dr. Ma is the Director of Advanced Transportation Collaborative at the University of Cincinnati. He has led research projects covering areas such as vehicle highway automation, intelligent transportation systems, connected vehicles, shared mobility, simulation modeling, travel behavior modeling, and artificial intelligence. So on slide number 3, we have a summary of the upcoming agenda. The ATDM and project overviews shown in Part 2 will be presented by James Collier. After that, Dan Lukasik will present the high-level guide and overview in Part 3 and walk through the first few chapters of the guide for Part 4. Next, Dr. Joshi Ma will walk through the remaining chapters of the guide to complete Part 4, and then in Part 5, I'll read off as many of your pertinent questions as possible for the speakers to answer. And so now I'll go ahead and hand it off to James.
All right, thanks, David. And let me advance the slide here. So, hello, everyone. I'm James Collier, as David said, and I'm just going to give a brief overview of ATDM and the project that we're presenting on today. Many of you know ATDM, but there may be some of you out there that are not aware of what ATDM. So really at its core, ATDM is about applying active management, which is the concept of taking a dynamic approach to a performance-based feedback loop that can be applied in a real-time setting. And that's what you see on the slide here. It's what we call the active management cycle. So in this cycle, transportation system is continuously monitored, and then that allows the system to be assessed. System is a key word here. We're not looking at a spot location or individual roadway, but truly the transportation system. Then based on the assessed state, various actions can be evaluated and recommended in real time. Then the implementation of these dynamic actions results in improved system performance, which is then fed back as part of the monitoring functions. So all of these decisions can be done in real time based on performance objectives and indicators decided by the agencies deploying the ATDM system. This slide shows that agencies typically take a stair-step approach to increased active management. The first step is usually static management. You see time of day, set it and forget it, those kind of philosophies. This involves a minimal effort. Moving to more responsive management involves another level of maybe risk and investment. This could involve taking actions to respond to current traffic conditions and reducing the time of degraded operations. This is a pretty widely accepted approach among the TSMO industry today. But then the last step is proactive management. This is more risky and more difficult technically to do. However, there's potential for big rewards, and we are seeing an increasing number of success stories throughout the country. And this involves the highest level of active management. So another key concept of ATDM is how ATDM can address demand across the entire trip chain in a dynamic manner. So ATDM is really intended to influence traveler behavior at all different steps in a trip. This can be done in real time, we believe, with ATDM, not just in the traditional commute trip reduction program or travel demand programs. One example, that's mode choice in the middle of the slide there. This decision on how a trip is made includes a decision to maybe drive alone, carpool, public transportation, etc. In an ATDM approach, consideration is made that dynamic information such as comparative travel times, real-time transit arrivals, schedule disruption information, other kinds of strategies can play a role in influencing mode choice on a real-time basis. So the key takeaway is that we can and should actively manage the system before, during, and at the end of the trip chain. ATDM broadly includes three categories. Active demand management is a category focusing on creating more fluid decision-making from travelers, especially at the mode, destination, and route levels. This could include strategies as you see there, congestion pricing, advanced traveler information, dynamic ride sharing. Active traffic management includes strategies like managing recurring and non-recurring congestion on the roadway, such as dynamic speed management, lane use, junction control, dynamic shoulder use. These are all examples of active traffic management. And then finally, last but not least, is parking management, and this focuses on improved parking management and information systems, and is also a key component of people's travel. So moving to the project that we're talking about today, it's really the aim of the project is to create a document to help guide agencies towards leveraging new technologies and data sources to enhance their ATDM systems from static and responsive management to truly proactive management. The document itself we're talking about today is in final review internally to Federal Highway. Will be published in a couple of months on our FHWA ATDM website, which will give you the link for that later on. But we really feel it's important to be aware of technologies and data sources available today and also be cognizant of what's coming next and start planning for that now. So this document we're going to be talking about is really about how new technologies and data sources can improve the way we implement ATDM concepts and solutions that we'll be using for the foreseeable future. As part of this project, we went through a detailed literature review and interviews with public agencies and private companies that implement ATDM solutions to see where they feel technologies and data sources are today and in the emerging future. So listed here are the emerging technologies and data sources that we identified through our review as practices commonly in use today. Traditional sensors and data collection devices, of course, third-party data. Over half the states today use some form of third-party data. And then you see listed there a number of ATDM strategies that are in common use today as well. And then also we included in the literature review and interviews discussion of future ATDM technologies, where the industry sees this going in the foreseeable future, along with the anticipated barriers and areas which are of need of future guidance as well. So as you see there, many envision data sources like Wi-Fi and Bluetooth, high-definition signal data, DSRC, social media, parking and weather data. The technologies that the folks in our literature review identified is coming in the near future, cloud computing, if not here already today, Internet of Things, big data and data analytics, and of course connected vehicles and autonomous vehicles. Some of the barriers are maybe not traditional, have always been around funding restraints and lack of resources and knowledge about these emerging technologies and data sources. And then one piece of guidance that was particularly bubbled up in our literature review is guidance on data fusion and validation and data analytics. This just gives you a flavor for the purpose of the project and an overview of what ATDM is. And at this point, I'm going to hand it over to Dan to give a high-level overview of the guide.
All right, thank you, James. Again, I'm Dan Lukasik with Parsons. I'm the PI for the project. So I'm going to walk through, first I'll give you a high-level overview of the guide, and then I'm going to talk a little bit about what's contained in chapters 2 and 3, and then I'm going to hand off the next chapter discussion to Joshi. So these are the chapters, this chapter 1 is an introduction. Chapter 2 discusses what types of emerging technologies and data sources we feel are very applicable to improving ATDM. So that chapter includes descriptions of what they are and what they do and how they could help. Chapter 3 talks about the specifics of ATDM solutions and how they can be enhanced using these emerging technologies and data sources. So I'll walk through that a little bit. I'll give you some examples on maybe the way you're doing certain ATDM things today and the way you could do it tomorrow and improve it using new data sources and technologies. Chapter 4 will go through some guidelines on what you should do within your organization and how you should change your planning specifically to accommodate this new and improved way of doing ATDM. Chapter 5 talks about design and deployment elements and methods for the new technologies and data sources within ATDM. Chapter 6 talks about how you should look at O&M with these new technologies and data sources in place. And Chapter 7 talks about some case studies, and we have 3 case studies included in the document. And then lastly, there are references in Appendix A of the document. So as James indicated, this document is under final review now, and we're just going to give you the highlights of it. So what is the purpose of the guide? Again, to give agencies or really anyone who's deploying this ideas on how you can leverage new technologies and data sources, really about how you can do it to enhance ATDM, and whether that's an existing ATDM deployment that you already have in place, or maybe you're looking to deploy a new one. How would you go about deploying that new one using these new technologies and data sources? So it talks about what are the viable emerging technologies and data sources that you can use. What are the things that you should consider when you're deploying the solution with those new things, and then lastly, discussion on how you would go about doing those enhancements in the guidelines for that. Our objectives of the guide are really to educate future implementers, increase awareness of ATDM and the new technologies and data sources that can improve it, to really look at impacts, opportunities, efficiencies, and challenges, and then investigate how agencies can prepare to deploy ATDM with these, the fast-changing technology world that we live in with new data sources, technologies. And really the end result that we want to see is we want to see improved ATDM through the use of this guide. Who's the audience for this document? So it's a wide-ranging audience. So it includes not only agencies, but companies that desire to deploy ATDM. It includes consulting technology companies, systems integrators, ATDM solution providers. So it's really anyone that's really a deployer, that even sells software, sells hardware, sells solutions. They're an end user of this as well. It includes, staff that are responsible for, legislative, executive decisions, policy, and regulatory measures. So, for example, some ATDM solutions are regulatory, some are advisory, so that might come into play here. Certainly includes our city, county, and state transportation planners, managers, professionals, and then it includes our project engineers, our designers, our financiers, procurement departments, as well as legal professionals. So it's really meant for anyone, whether you're agency, private sector, or a solution provider, to help give guidance on how you would go about deploying better and more improved ATDM. So a little bit on the guide walkthrough here. So I'm going to talk about Chapter 2, which really is the chapter that presents what are the emerging technologies and data sources that can be applied. And James talked about the active management cycle. So we do get into how we would apply them to the different parts of the active management cycle. The chapter did discuss the literature reviews that we conducted and how we gathered the information. We did interviews various public agencies and private companies about, what they have done with using new technologies and data sources, or what they plan to do, and what they think are the new emergent things to look at. So we looked at data sources, and we looked at from the perspective of sources that come from vehicles, from travelers, from new infrastructure, from crowdsourcing methods. So that was all in there. And then we looked at technologies from data analytics to cloud computing to really everything. So let's maybe get into a little bit more specifics here now. So this is a listing of the emerging technologies that are discussed in the guide. So we kind of categorized it into these categories of data technologies, vehicle technologies, decision support system technologies, and sensor technologies. So, as an example, I'm not going to talk through each of these and what they are because we really don't have time, because there's quite a few. But, data technologies include, blockchain, which is a different way to store data and make it secure. Big data technologies, we certainly hear a lot about big data and cloud computing and how large amounts of data can be used and analyzed to improve the way we operate things. Crowdsourced data. So, we have crowdsourced data sources today, like Waze is a crowdsourced data source, and they give that information freely to public agencies. And then on the vehicle technology side, we have certainly connected vehicles and automated vehicles. So, there's means not only to receive data from them, but also to send information to them. Maybe it's directly to the vehicle itself, or maybe it's to an aftermarket application that's used in the vehicle. We have decision support, so we hear, a great deal these days about artificial intelligence, which includes machine learning and deep learning. This helps make, more accurate and improved decisions on the way we do things, but it also learns over time, whereas in the traditional methods, the systems are a little more static and they don't learn and improve. We hear about cloud computing and edge computing and this trending away from maybe truly fully centralized solutions toward maybe solutions that run in the cloud, solutions that run at the edge, or a hybrid of edge, central, and cloud together. Sensor technology, so we hear a lot about, things like even smart lighting sensors and gunshot detectors for public safety, air quality monitoring sensors, Bluetooth, Wi-Fi sensors. These are all sensors that I think, we should be looking at, and they're ever changing. If you go to a trade show, you can see all sorts of new sensor technologies on the market today. And then data sources. So here's a list of the data sources that are discussed in the document, and they've been categorized in these 5 categories. So connected traveler data, connected vehicle data, connected infrastructure data, map technologies, and then other data sources. So, we mentioned a little bit about, getting data from crowdsourced sources like Waze, connected citizen applications. There's even crowdsourced video applications. We know about, connected vehicle data that comes from, say, the basic safety messages. And then there's other probe data sources. There's vendors that sell probe data that really comes from, say, cell phones inside vehicles. Verizon and Inrix here, they all sell sort of floating car data that can help us with information on accidents, can help us with information on traffic flows. And then there's connected infrastructure data, obviously our DSRC data from the roadside, our SPAT challenge information. High definition signal data is often used, especially in the days when we're talking about ATSPMs quite a bit these days. There's active traffic management devices like signals, camera signs, weather information, Internet of Things, any device that's connected via the internet communications. And then map technologies, there's crowdsourced mapping, high definition mapping that gives us, lane level accuracy that is often very useful in ATDM applications. Real-time trajectory data, what's the trajectory of a vehicle in real time, and how can that be used to help, say, identify accidents, incidents, or sudden changes in conditions. And then there's other sources, there's high-definition mapping, mobile sensors, real-time turning movement count data is available. So these are all things that we've identified can help improve ATDM solutions. So Chapter 3 digs into the ATDM applications themselves and how those sources and technologies that we talked about can be improved. And we did identify really how the improvements could be made by looking at the active traffic management cycle, which is, the four parts of that are collecting and monitoring data, assessing system performance, evaluating and recommending actions, and then implementing those actions. And then we presented 3 different use cases in the document for how these new technologies and data sources can improve those use cases. And the 3 use cases that are discussed in the document include recurring congestion on freeways and highways, a major incident on a freeway, and then parking near an airport is another an APM type application, and we presented use cases for that. And I'll show you an example here in a second or two about how we presented that information. So here kind of is, we're walking through that active management cycle, and we're talking about how ATDM is done today and how it can be done tomorrow using the new technologies and data sources. So you can see on the left, the first kind of stage of the active traffic management cycle is monitoring systems. So today we monitor our systems. We use traditional type sensors like intrusive inductive loops or radar sensors or magnetometers or video analytics sensors. We get data from computer-aided dispatch systems on where accidents are in the detail. We even get data from the media. We get information from directly viewing CCTV cameras. We get data from roadside systems like signals. But tomorrow, we're gonna get a lot more data from vehicles themselves. The vehicles will tell us where they are. They can tell us if they've been in an accident. They can tell us their exact speed and their exact position on the highway. We'll have, we already have a lot of crowdsourced data sources. They're going to give us some really accurate information fairly quickly. And then probe data, we talked about the fact that there's a lot more probe data sources and the accuracy is improved. And then the Internet of Things, devices that are connected via the Internet are made available and that data is used. So this is kind of an example of the first stage of ATDM and how it looks today and how it could look tomorrow. The second stage is really the assessing system performance stage. So in current ATDM solutions, there's algorithms that assess the data that's fed in. Maybe they estimate travel times. Maybe they estimate what the variable speed limit message should read. We use video image processing systems and cameras today to help assess performance. We measure travel times typically today using maybe some sort of analytic algorithm. And then we estimate things like event travel times using that. Tomorrow, we have this world of cloud computing and big data. It can help us assess system performance. And I think one of the challenges that we face is that, tomorrow there's going to be really large volumes of data available to us, and it'd be difficult to crunch that data unless we looked at some of these, big data cloud computing technologies. We can integrate online microsimulation tools to help us assess performance. There's examples of that being done today. We can use advanced video analytics to do wrong way detection, fire detection, all sorts of things. We'll use, as I mentioned, ATSPMs as part of the way we'll measure things tomorrow, and many people are doing that even today. And then we'll perform traffic and event prediction, and we'll use artificial intelligence to do that. So again, this is a look at the second stage of the active traffic management cycle and how it looks today and tomorrow. The third stage is evaluating and recommending. So we've got all that data, we've assessed the performance of our system using that data, and now we are going to recommend what to do. So today we use, automatic incident detection systems to identify accidents and where they are. We use rules-based decision support systems that recommend what to do if we're going to post messages on signs, or we're going to post messages to websites, or we're going to push information to cell phone apps. We have traffic management algorithms. We have CCTV camera systems that help us evaluate and what's going on and recommend what to do. And then lastly, we use other types of field devices. But tomorrow, we definitely see AI, machine learning, deep learning as part of that decision-making process. And one of the benefits that I already mentioned is it can actually learn and improve over time on how to recommend, which is probably one of the biggest advantages to us. Real-time multimodal decision support systems will be here tomorrow. It's not just about one node, it's about multiple nodes. We see traffic prediction systems, event prediction systems. So again, becoming more proactive. Let's stop deploying systems that make recommendations only on the current data we see. What will it be like based on the future that we see? Maybe that's just 30, 45, 60 minutes into the future, but that's a more proactive method. And tomorrow, maybe blockchain is part of that puzzle for evaluating and recommending, and certainly cloud computing. And then implementing dynamic actions. So the last phase is really we're going to implement our actions. So today we send messages to highway message signs or highway advisory radio, 511 systems, traveler information websites, phone applications like 511 applications. But tomorrow, we're going to talk directly into the vehicle or directly into apps being held by users, although they're not going to drive with their apps in their hands. That's against the law everywhere. But connected autonomous vehicles, we're going to send our message to CAVs or dynamic mobility applications. As an example, today one of the ATM applications that is typically used is variable speed limits. That's posted on highway signs. Tomorrow, we'll send that recommendation on speed directly into the vehicle. So that's the smart mobility apps that I talked about. There's a lot of talk about traveler incentive systems as well tomorrow, traveler incentive systems that say, hey, maybe if you take an alternate route, hey, maybe if you slow down, Maybe you can use different lanes or leave it a different time of the day, and you'll be incentivized to take that different time of day, different mode, different route. That'll help overall congestion. And that'll be done by systems that recommend that to you, maybe via website, maybe via smartphone app. So that's kind of just some examples of how we see today and tomorrow using the data sources and technologies. And let me walk through kind of one use case. In a current, say, ATDM deployment, we gather data, we monitor congestion on our highway or our roadway using intrusive and non-intrusive traditional sensors. Maybe we have probe data. Maybe we have some ABL data from buses or other vehicles. And then we determine what is the congestion reduction method that we should use. We determine there's a lot of congestion. We have some algorithms that sit in the system that look at the data. And then we implement some actions. Some of those actions could be, let's activate some part-time shoulder use. Let's activate ramp metering or change the ramp metering rate. Let's implement some junction control. Let's implement dynamic pricing. Let's adjust our signal timing. We see a heavy amount of congestion. And then the data is stored to a database, and it's analyzed for future use. So this is kind of giving you that, what does that current typical use case look like? And here's what it could look like in the future using these new technologies and data sources. So now I've taken that same picture, and now we're showing new data sources, connected autonomous vehicle data, IoT sensors, Waze crowdsourcing data, real-time turning movement counts. That's all feeding into our new monitoring and congestion engine. So now we're getting congestion information more quickly and more accurately using new and more enriched data sources. Then we're going to look at the next stage, which is what are the congestion reduction methods that we should use. So that's when cloud computing and big data analytics comes in. So it's going to help give us kind of those more appropriate implementation actions because it's able to calculate and use large volumes of data and take advantage of the power of cloud computing and big data analytics. Then we're going to look at, say, how artificial intelligence assists with those recommendations. So that AI can sit on the premise, it can sit in the cloud, but it now can tell us, oh, with all this large volume of information that I have, I recommend you do this. And then we're going to implement our system actions. So, now we see that mobile apps and CAVs will be part of who's going to receive the recommendation on what to do and how to behave. Then we're going to store that data, and now we have alternate technologies to store data with blockchain. And then, there's lots of big data, business analytics tools, business intelligence tools that are available in the cloud to help us analyze our data more accurately. That'll help us behave better in the future. And then the end result that we hope is that we've taken our ATDM solution and congestion is much more measurably reduced as a result of using these new technologies and data sources. So the document has some other use cases that are presented in a similar manner to this one. And now I'm going to turn it over to Joshi to discuss the next chapters.
Okay, thank you, Dan. So starting from chapter 4, 5, and 6, I'm going to talk about some key points we put in the report about planning, about design and operations and maintenance of the ATDM solutions. So chapter 4 is the planning and organizational considerations of ATDM solutions. So here is the 5 different important areas I'm going to cover. But before that, in addition to the ATDM website that Nilu mentioned in the beginning, and next to chat box, you can find it. Actually, there's another website from Federal Highway we put in a report as well about organizing and planning for operations website, which has a lot of materials that it can refer to specifically about planning and organizational considerations for any operations solution, including ATDM. I'm going to next slide. So the first area of planning is organizational capability. So as James and Dan mentioned, ATDM is a very complex solution, more complex than traditionally. So to adjust to ATDM solutions, organizations, agencies are really required to proactively managing the transportation systems. James talked a little bit about this figure already, the stair-stepped approach toward increased active management, starting from static management, then responsive management, followed by the sort of the optimal proactive management. Some agencies are ready for it. Some agencies with relatively low level of system management and operations are maybe not entirely ready for ATDM deployment. Federal Highway actually published traffic management organizational capability mature model to aid in assessing an organization, provide a set of tools that it can assist any transportation agency managers with a self-assessment of their organizational capability and development. The maturity model includes four different key areas: staffing, education, organizational changes, and new business processes. Federal Highway also provided a capacity maturity framework, CMF, that is really structured around the four levels I just mentioned and provided recommendations so for agencies to be able to improve, to help agents identify the current state of their operational programs and provide guidance for improve the levels of program effectiveness. Second area of planning is the planning for modified ATDM operations in these four different areas. Scenario planning is very critical, very helpful in developing ATDM solutions. These scenarios really can vary by specific environmental or background characteristics, such as the deploying ATDM solutions during planned events, like work zones or special demand generators, or it can ATDM in response to incident or emergency conditions, such as closed lanes or inclement weathers. Preferably, agencies, in our report, we recommended that agencies should describe ATDM operational scenarios from a user perspective, inclusive all different types of day-to-day operations. These planning elements that may include like agency roles, responsibilities, like travel information needs specific to the dynamic nature of ATDM solutions, system interoperability, stakeholder roles, and so on. And in the initial stages of scenario planning, usually rough simulation exercise can really come in and help agencies assess different ATDM scenarios and different strategies under those scenarios to understand the impact of specific components. Second is data, new data sources. From operational purposes, data often require detailed granularity that can allow analysts to examine the potential for incremental changes at specific locations of their ATDM deployments. Usually you need longitudinal data, which also referred to as those time series data that are necessary for seasonal and year-to-year comparisons. This data needs usually driven by the establishment of performance metric that's been mentioned by both Dan and James that I will also talk about quickly in a minute. So examples of this data could include travel demand models, particularly the output of the travel demand models. This is very critical for demand management. And other data like the transportation management center data, transit ridership data, crash records, citation data for enforcement. And also need to note that more and more frequently agencies now relying on private sector data like INRIX and HERE travel time data related to measuring their mobility and congestion. These data, new data sources like crowdsourcing data sources need to be considered as well. Third is about technology use and expertise. This really considers how agencies are responding to upgrading, replacement, and integration of systems in the world of these rapidly changing technologies. Ongoing maintenance, management, replacement, upgrading of the system is really challenging to organizations, and particularly a lot of new challenges in addition to conventional ITS projects will come along with this ATDM solutions, including the technology that are usually unfamiliar to many agencies. Additionally, the specific dynamic nature of ATDM solutions really requires a lot of sensor and communication investment, as Dan mentioned, that increases the complexity level of ITS infrastructure that the agencies need to operate. So therefore, agencies will need to ensure that capabilities in place to support its complex systems and ensure reliable operations of to optimize the system performance. Lastly, but not least, the training. Training at different areas of staff for staff education and training is very critical, as I mentioned, because of the new level of complexity. A few examples of training can include like peer-to-peer exchanges with other transportation agencies who had some experience or experienced in operating similar ATDM solutions, or some structured monitoring and training between experienced operators and junior operators. The third area of planning is setting objectives and performance measures. Nobody can overemphasize the importance of the performance metrics. This is really used in the indicators, right? How well your transportation systems are performing, and are used in different ways, like tracking your progress toward your operational objectives, which you set in the beginning of your ATDM proposal, and identify needs of system performance deficiencies, assess potential impacts of maintenance operational strategies, and also important, communicate the progress to the stakeholders, mostly the travelers, how the new solutions is improving the system. Usually the ATDM solutions performance metrics should be SMART, as you're shown here: specific, measurable, attainable, realistic, and time-bound. They should clearly relate to the agency goals and objectives, and should be driven by the capability of collected data and conduct analysis, because some of the complex performance measures really requires large amount of data for calculation. For example, travel time reliability, right? If you have a goal of travel time reliability, you have to calculate some specific performance measures like travel time index, buffer time index. Those will require multi-year of data on your transport system to be able to calculate that reliability. Also, here is another example with objective congestion management or reducing the congestion. You have then specific performance measures that you can quantify, like highway delay, travel speed, vehicles hours traveled, and passenger travel times. So there are different levels. Then there are performance measures related to safety as well, to sustainability and livability. The fourth area is for planning is analysis modeling simulations. We talk about these tools can help you at different stages of your planning, of ATDM planning. Sketch planning methods you start in the beginning. You have some rough planning tools they can use to very quickly understand different alternatives and their performance measures. And you go with sub-regional planning usually with travel demand models and post-processing methods, post-processing the data from travel demand models. Then you have multi-resolution methods that really use microscopic simulation or megascope simulation, that when you come to subcorridor level, to conduct detailed analysis, to understand detailed parameters of your system. Actually FAST Act dictates that utilizing AM's tools to the fullest and most economically feasible extent practicable to analyze highway and public transportation projects. These tools have been evolving all the time. We have tools ready to evaluate some more conventional strategies, or some like variable speed limit or dynamic travel information. But some of the new emergent sources and technologies like connected automated vehicles, AMS tool for them is ongoing research. Federal Highway has many projects developing tools for that, and it will be available for the agencies to use. One thing I want to mention is the recent Federal Highway effort to develop AMS testbeds for dynamic mobility applications, DMA applications, and ATDM programs. I think 6 or 7 the testbeds were selected, and different modeling tools and different strategies have been selected to demonstrate the effectiveness of using AMS tools that have been published on the Federal Highway website, and agencies can refer to it. Last is the program and budgeting. James mentioned in the beginning that this is always the limited and constraint for a lot of transportation projects because of the resources constraints. Federal policy mandates and guides many components of planning, programming, funding projects. ATDM solutions can be included, and usually this is the practice now, within an improvement or long-range transportation plan, once an agency or sponsor determines that it can help improve upon statewide or regional or local goals. However, obviously ATDM solutions will need to compete with other transportation projects to gain approval for funding. When you try to understand and calculate the life cycle budgets for ATDM, it's not just acquisition costs, but also, as many other projects, recurring costs, O&M costs, capital costs, and refreshment costs. But obviously, there will be a lot of the new components of these costs related to emerging technology and resources that need to be accounted for. Chapter 5, so much about planning. Chapter 5 talks about design and deployment elements of ATDM solutions. We will cover this data sources, system platforms, and also infrastructure, system testing, and public outreach. Many of these, as I said, many of these technologies are transforming, ATDM practices and enhancing really the state of art of these transformations, are forcing agencies to consider deployments in new ways. We have summarized the design elements from two perspectives. One is logical data management. The other is the physical data management. So the logical data management, LDM, is really how agency scopes and prepares data in a manner that supports analysis of the system, including geographic, temporal, jurisdictional, functional, and model boundaries. Agencies are really recommended to fully investigate implications of logical data management as an initial step of any ATDM solutions. I want to mention in 2017, Federal Highway provided a guidance document entitled Scoping and Conducting Data-Driven 21st Century Transportation System Analysis. In that document, it defines a continuous improvement process really to help agencies understand the integration of data-driven dynamic operational analysis within transportation system management. To give an example, what does it really mean? For example, consider the task of integrate connected vehicle data for ATDM. Based on the desired outputs, right, for analyzing CV data and what do you want to use for this data, the process and technologies implemented to manage the data can differ greatly. Do your TMC want to host all the to store all the raw data from connected vehicles? Do you want to just analyze the data at the edge through edge computing and really store and use process data in a TMC? So these are different practices depending on your goal defined in the beginning, and this really drives different types of design, the logical data management design. The second is about physical data management. It is how the agency designs technology systems that support scalable, cost-effective, high-performance ingestion, transformation, analysis, storage of data. Here is the diagram as you show in the slides, 5 different V's of big data, as you've probably seen in multiple places when people talk about big data: velocity, volume, variety, value, and veracity. Connected travelers, vehicles, infrastructure is what we focus in this project, really will drive the big data era. I will say that finally with this technology, big data in transportation finally come. And this new data will require IT infrastructure, new processes and skills of staff capable of handling this data acquisition, marshaling, and analysis process. I want to mention a little bit about then the data sources, the big data process model shown here. It includes, data acquisition, data marshaling, data analysis, and data action. Data acquisition is easy to understand, the collecting data from your resources. But it's not just conventional data, as I mentioned, right? But it's also additional layer of, new sensors, new sources of data, like crowdsourcing their private sector data, right? Then in this process, you need to consider license for data use and privacy issues for the data that exists. Second, data marshaling, which is really the sorting and the storing of data. There's large volumes of data, unlike before, and they're constant feed, and you need to consider data that will be, how the data will be consumed, right? So consumed in real time, consider ACES, API with resources available, or you focus more of a historical storage that's enough for your performance reporting. I know you need to deal with sorting and storing of structured data. That's the data we're used to deal with. But also we have semi-structured and unstructured data, those text data, voice data, image data. And these are really going to be prevalent through connected vehicles and automated vehicles with advanced video processing technologies. and modeling of this data from raw form to highly structured, depending on the source and use of your data. The third is data analysis, to find insights from your data. That's very critical to understand how your systems are performing and even make better decision making. Again, there are a lot of the new data sources like text, voice, data analytics capabilities will be needed. Like, for example, you have a lot of images. Deep learning, the convolutional neural network that will be used to process data is going to be very helpful. One thing I want to mention is in analysis, the predictive modeling. This has been very a critical component of proactive management. The predictive modeling is really when you have conditions, certain conditions like inclement weather, when you implement certain strategies, what your transportation system can look like. For example, for weather responsive management, if there's adverse weather, I'm going to implement VSL or do nothing, right? If I do nothing, what's going to be the transportation system going to look like? If I implement a VSL or implement some other strategies on my playbook, what's going to look like? So this is really the gist of predictive modeling. The last is action, right? Use this insight to make decision making like real-time routing or generate real-time alerts. That will help the travelers know what's going on the roads. So data platforms to deal with this data obviously is critical. It's a new thing for agencies. There are three different types: cloud, premise, and hybrid. Now, cloud environments, you probably all know, it's service platforms that provide subscription-based services, including infrastructure services, including like computing power, networking, security. It also includes software services like database, business applications, IoT services, and more these platforms include machine learning capability that you can really analyze data directly on their platform. So three largest providers, as you might have heard of them: Amazon AWS, Microsoft Azure, and Google Cloud. Next, premise environments. It's really your data center. The premise environments are owned and operated by the agency or through some contracting services. Premise environments typically operate in one or more managed data centers utilizing networking, hardware, software services to run their own applications, depending on the agency needs. Hybrid environments, as the name infers, it's really hybrid between cloud and premise. That's actually been used quite often. And it also can refer to you use the cloud service from multiple providers, commonly referred to as multi-cloud services. So there's different ways to structure data platforms. This really depends on the agency needs. Infrastructure, again, as any other traditional ITS deployments, ATDM will require some additional infrastructure design and deployment. So when you design this infrastructure, you want to make sure that some fixing objects where you newly deployed, you will not really impact the clear zone on your highways, right? Sometimes it may impact the highway clear zones. Then we want to make sure that you relocate them beyond the clear zone during the design phase, or shield them with barriers if they are in a place where they are likely to be struck. One example is the shoulder-mounted signage or the overhead sign that manage the gantries that usually happen. Now, this, as shown here, all this new field elements need to meet all different geometric designs, like the clearance minimums, different controlling criteria, so minimum requirements prescribed by AASHTO. So that's something that need to be taken into account. Next is testing of your technology. If you're familiar with the system management view diagram, this is really the right wing starting from the right wing of the V diagram. Once you complete the design, you have the plan for, or you have to conduct the unit testing, subsystem testing, system testing to ensure your process is performing as it desired. Lastly, but not least, public outreach. You need to let travelers know about the importance and the functionality of your ATDM solutions. But also, I want to mention one important thing: is data privacy and cybersecurity. These are of vital concern to not only agencies but also the general public. So the ATDM technology and data solutions are really tricky topics for agencies, I would say. This cybersecurity and data privacy should not be hidden from the public. This balance, you should let public know, and this balance between public outreach and security and should be done through public outreach. And this is actually not unique to the transportation domain. In a lot of the emerging technologies deployment, this is an ongoing issue, and a lot of the experiences from other fields can actually be borrowed upon. From this slide, we're going to talk about the next components, operations and maintenance considerations. O&M has been, we'll talk O&M from two perspectives. One is some routine issues, as you've shown here for different aspects, but also we'll talk about one particular issues related, very of critical concern to ATDM or high-tech deployments and future-proofing. First, as I mentioned a little bit before already, cybersecurity and data privacy, right? Traditional ATDM systems or ITS systems, they are really sort of closed from the standpoint of that they communicate with sensors, devices, and external systems that are on their own private network. But ATDM new solutions are different. They are taking data from different sources, interfacing with the people's vehicles. They are taking private sector data in real time, streams those data in real time. So data privacy and cybersecurity becomes a critical issue. One thing is obviously connected automated vehicles, right? CAV deployment has been a quadrant of emerging technology, but it also relates to severe cybersecurity data privacy issue. For example, it can access the people's vehicle bus, right? It's a cybersecurity issue. The data that it can potentially be used to track vehicle locations is definitely a critical data privacy issue. Some of the ATDM solutions, for example, the MIT system, the multimodal intelligent signal systems, are really designed to exploit this type of technology, CAV technologies. So archiving, documentation, analysis of the resulting data may be very critical to success of these deployments. And if you look at the key questions here on this slide, you need to answer to address these two concerns. Who will pay and collect, store, and share data? Who can sell data? To whom? And are there any privacy issues? Who is allowed to access the data? What purpose are data allowed to be used for? And is there any data agreement that are in place to manage the cybersecurity data privacy? And usually, for the comprehensive data management plan, the cybersecurity data privacy should be, a critical component of the current data management plan. Next is performance monitoring, just corresponding to what I just talked about. Key questions really: how will performance of new technologies and data sources be monitored? What tools should be installed? What are the responsibility for agencies with performance monitoring, and what type of key performance indicators? We talked about a few performance indicators in the planning stage. Real-time operations, you can add to new sort of real-time operations related performance measures to capture the performance of your system. One example shown here, this is really a transit system that that I think Pittsburgh has deployed. This is really using automatic passenger counters and automatic vehicle location data to understand the supply and demand of their public transit systems. Obviously, the transit agency can use such a system to understand how their how their system performance looks like now. And they can use the data also better understand demand and supply and provide better services and make better decision makings, such as scheduling of their transit systems. The last issue about the O&M is very critical, unique, is future proofing. The big challenge, as I said, of this technology deployments is how to really keep the system current. Because the technology is evolving so fast. You cannot really make it truly future-proof because new, better technology will always come, but there's always steps that can be taken to help ease the impact of evolving technologies. For example, you can perform, before your deployment, right, you can perform technology maturity and evolution assessment before implementing. For example, you can ask questions like how many companies or vendors are doing things like this, how prevalent do the technology industry experts will see this future of this technology, and what are the size of the the companies or deployment sites that are using this technology. So this will help have a general sense understanding this technology and the future development of this technology. Then you can have select technology options that offer flexibility, scalability, and consistency. One best example is cloud computing, right? Instead of having a data center, everything stored locally, the cloud computing, those services, Amazon, Google, Microsoft, they are updating it for you with the latest technology. So the service you get is really the current technology. After implementation, you can perform some regular change control meetings, typically with a change control board, CCB. This will allow agencies to predict future changes and plan for them in advance to sort of make sure a system is in line with the latest technology. And then you can also build future-proof IT plans, creating continuing education programs that will allow your staff to constantly learn about new technologies and their trends so that they can be brought forward as part of future-proofing exercises. Chapter 7 is the case studies. As Dan mentioned, we provided 3 quite different case studies in the last chapter of the document. The first one is San Diego Integrated Corridor Management System. This is active traffic management and also demand management components in there. It uses basically different artificial intelligence within these decision support systems. Obviously, they're collecting all the real-time data and make use of online simulation, microscopic simulation to conduct traffic prediction, to be able to understand, okay, what are the best ATDM solutions will be implemented offline, but also implemented online. You will know that online, what is the best strategies in your playbook should be implemented. The second is quite a unique project done by Stanford University, their congestion parking relief incentives Cape Rape study. This is active demand management and parking management. They use because the focus of this project is to encourage travelers to shift to the peak, the shoulder of the peak or the off-peak periods instead of traveling to the university campus area during peak periods because the traffic performance is so bad. So they actually offer some incentives, some credits that people can use for other entertainment or grocery purposes. And the results are very, very encouraging that they find significant differences, and people are even choosing non-motorized modes by the end of the experiment. The third one is Charm project in the Netherlands. It is a typical ATM project that done by, I think project funded by European Union. So emerging technologies or data really they can take into consideration of the existence of connected vehicles, how those connected travelers and infrastructure can help traffic prediction. And they also, one unique thing is they use in-car applications. Some of the messages are communicated directly to the the drivers and to make better decisions. And these all the information communication also driven by the AI and machine learning algorithms. So I'm not going to go into too details. Our document, when it comes out, you can refer to the details of this experience. But all of them, 3 of them, sort of show the successful stories of active traffic management, active demand management, and parking management. I think that's the end of my partial presentation. David, hand it over to you.
All right, thanks a lot, Joshi. I guess everyone completed on time. I didn't have to do any 1-minute warnings or anything. So I've collected a few nice questions here from the chat pod. We'll get to those in a moment. Before doing that, I just wanted to go ahead and show on the next slide, number 42, we have some contact information for some of the key players of the project. If you've got some follow-up questions, maybe that don't get addressed today, or just want to send something more private than public, you can feel free to contact any of the individuals listed here. We have their email addresses shown on the screen, so that's the presenter contact info, and we'll try to show that both before and after the Q&A session. And I also wanted to reiterate something that James said towards the beginning, which is that our Enhancing ATDM guide is going through final reviews at this time, and the plan is for that to be available by the end of the year, I believe, on the FHWA website. Okay, so now what we can do next is take a look at some of these questions that came in on the chat pod or the chat feature during the past 3 presentations. Probably want to start with the question from Mike Petrick. I'm not sure if I'm pronouncing the last name correctly, but Mike's original question was, please give a layman's definition of the blockchain technology, and furthermore, what are its proven and measurable benefits? And this was during Dan's presentation, so I'll give Dan the first opportunity to answer this question, but it's sort of open-ended, so we'll check with the other 2 panelists as well. But Dan, why don't you go first?
So blockchain is really a method to store information in a decentralized way or a distributed way that can make things more secure, right? So are there any kind of proven measurable benefits? I think the proven benefit is kind of it's a more secure method. We see blockchain used in certain, like say for example, we see it used in not really ATDM, but say tolling applications where we're storing, license plate information or transaction information, that sort of thing. That kind of may make its way into, ATDM more, but it's just really benefit is a more secure way of storing information that you might want to look into investigating. And it's really about resistant to modification. So if someone got into a database and wanted to change the record, change the transaction information, blockchain is an excellent way to prevent that from ever happening. In fact, it's very difficult. So hope that explains it. I don't know, Joshi, maybe you have some other things to add.
Yeah, Dan, I think you give a great introduction, general about blockchain. I think you mentioned a few good points. It's a decentralized distributed system that you can store your data and also process your data, because it's decentralized distributed. And also because they're decentralized distributed, it's very great for the security aspect of the data, right? Nobody can, because I mentioned a couple of times in my presentation is the cybersecurity concerns of the ATDM or emerging technologies and data sources. So with the blockchain technologies, with the distributed or decentralized approach, nobody can really go there and attack, modify your system, attack your system. So that's another layer of security-proof technologies for the ATDM solutions. Also, because of these decentralized, it will be more efficiently, even operational-wise, that you can more efficient manage your system performance using some the existing centralized approaches.
Thanks a lot, Joshi. James, did you want to add anything on blockchain?
No, thanks, David.
Okay, thanks for the question, Mike. We had a second question from Solomon. He said his was answered. Maybe we'll go back to it to see if there's any additional real-world examples of AI currently being employed. But maybe I'll skip ahead in priority to Stephen Levine, who asked, has crowdsourcing been used to estimate real-time volumes? Anyone want to take that?
This is Dan. So I know there are some data sources that use crowdsourcing or application crowdsourcing that have been discussing that they can estimate volumes. I don't know anyone actively using it yet, however. Doesn't mean they're not, but I know that there's been a lot of discussion that some of these crowdsourcing apps can estimate it, but I think I'll emphasize the word estimate. Sorry, I don't have more information, yeah.
So this is Joshi. So I can add to Dan's answer. So I think, first of all, the crowdsourcing data, if you're referring to the like the smartphone data that's sending to the TomTom, they receive directly, probably a lot of the agencies will not have access to the data. If you, in terms of crowdsourcing data, if you're referring to the process to crowdsourcing data, which is being sold by like INRIX here, the travel time data, that is, first of all, those travel time data, crowdsourcing data, those, they cannot, it's hard for them. They are really travel time data. They are no, it's hard, usually you should use, you use sampling approaches to predict the demand of the traffic volume. I know the University of Maryland CAT Lab, I've seen actually there's a webinar a while ago, I think a year ago. They have done some research on that. I would say this is still research ongoing. They're trying to use, obviously, neural networks which capture the relationship between sort of estimated travel time, using the travel time, use some of the ADT data, other, sort of a volume-related parameters to predict what is today's, the current time and traffic volume. So these, as Dan said, these are all estimates, sort of a prediction approach. There's no direct measurement because crowdsourcing data by means the probe data is not really a vehicle-by-vehicle count. But there is research going on, and you can refer to the CAT Lab research.
Yeah, this is James. I guess the only other thing I'd add is that the other part of Steve's question is whether or not this is available in real time, and that makes it even more difficult to provide if you're using some kind of aggregation of data sources and to provide an estimate in an archive manner. That's one thing, but to do that in real time is even much more difficult. So I don't think that's available today. Not necessarily may be done in the future, but I guess the other point I make is that doesn't necessarily mean crowdsourced data is not useful. It just means if you can integrate these different data sources in with your existing or traditional data sources, which may provide volume data in real time at specific detector stations at specific points in your network. That's really the key and the benefit of using a data source like crowdsourced data, where crowdsourced data can provide a lot of insight in areas of your network where you don't have traditional sensor systems, and then those traditional detector or sensor systems can't provide real-time volume that maybe crowdsourced data can't provide. So if you can integrate those two data sources together into your ATDM system, into your ATMS system or your traffic management software, then that's where you can really provide a lot of value.
All right, thanks a lot, panel. Might move on to the third question out of 4 now, which is the second question from Mike Petrick, which is actually the one on the bottom. It has 2 sentences. I'll just read the second sentence, and maybe you can read the first if needed. What needs to change for understandable performance measures to be developed and communicated to the folks that actually determine and allocate funding? Anyone want to take a shot at that?
Sure, this is Dan. I'll start. So I think some of the technologies that we discussed includes kind of these advanced analytics tools that can develop dashboards that can make these types of performance metrics easily available. And there are some really good examples out there today of, these are the number of accidents that happened on our highway. These are the number of accidents that got reduced through deploying of this technology. This is the amount of overall delay that we had last year. This is the amount of overall delay that's being faced by the public this year after we deploy these technologies. So, I think it would be good to see some of these dashboards that, as the question indicates, previously have only been available, probably internally. Maybe we make them more available publicly using these tools, and then everyone can kind of see the benefit. So that's my thought.
Josh and James, anything to add? Okay. Let's see. Sorry, James, you want to go?
This is James. I was waiting for Joshi, but yeah, that's a really challenging question. So it's not a technical answer. It's more of a policy and institutional answer. So that's why it is challenging. So you need those, like Dan said, easily understood dashboards that you can provide a complex level of measure into something that's easily digestible by decision makers in a quick manner. But also more so, I think, is integrating those performance measures into your planning and project development process and your funding process as well, so that those measures can better line up with the way that your agency provides funding for different projects. And so there needs to be an alignment between the performance measures that you're trying to use that can maybe more readily ascertain the mobility benefits of your operational system and have that align with your funding stream and project development process. And that's the real culture change that needs to take place within the agency.
This is Joshi. James, I was waiting for you as well. But I'm trying to understand Mike's question because from my experience working with, let's say an MPO, right, funding for a ATDM solution or other traditional projects, each MPOs usually publish their project selection criteria. I think they usually including safety, congestion reduction, and environmental benefits. So the mobility performance you're talking about here is sort of the congestion reduction benefits, right? Because when you apply for the projects that to be funded by a certain MPO, usually, at least the ones I used to work with, you have to indicate, okay, what is the congestion reduction benefits of your particular project? So I think that's sort of already being considered as part of the funding allocation process.
All right, thanks a lot, Joshi. I think there was only one more technical question left. Before we get to that, just wanted to point out some of the questions were about downloading the PowerPoint presentation, and I think Nilu answered that in the chat pod, but in case anyone didn't notice that, in Adobe there's the download window, and you can download the presentation right now if you wish to, but also later on it can be downloaded from the NOCO website. So that was sort of the non-technical question that came in from 3 people actually. And so the final technical question was from Solomon, and he said his question sort of got partially answered on slide 40 about real-world examples of AI recommendations currently being employed by agencies. And so we saw a couple of the case studies there. I just wanted to give the panel one more chance to mention any other maybe real-world examples of the AI recommendations currently being employed by agencies.
Well, I mean, one of the good ones was mentioned in Chapter 7, which is the San Diego system uses AI to recommend response plans and then assess those response plans in real time to determine their effectiveness. So that's in place today. But as another example of AI, we're seeing kind of your narrow AI being deployed in places with voice data assistance, which essentially your Alexa type app where people can speak commands and then the system responds. And some of the key benefits are that usability, but also single voice commands can actually replace 10, 12, 15 mouse clicks that you might use if you're using, say, an active traffic management application as an example. So those are some examples that I'm aware of.
And I can add to what Dan just said. I think there, if we talk about AI, right, it's kind of a very general field. So in particular, like the predictive modeling, I think or data-driven estimation, I think a lot of agencies are doing that right now. Basically using all those data collected, as long as you're clustering those data, using those data mining techniques, and even make some predictions of what the condition is going to be. I think these are AI components implement TMC or other maintenance operations. One example I want to mention is a sort of pilot project Federal Highway is doing called IMRCP, Integrated Modeling for Road Condition Prediction. That's actually an ongoing 4-year project now. It's been the project team deployed a system that tracks all the data, gets all the data, and then use the data to predict the traffic conditions with different incident road weather conditions. So how this has been deployed in the KC Scout TMC actually for kind of over 2 years now, I think. So this is a kind of example of pilot project. So James, sorry, I said over you.
Yeah, no, thanks, Joshi. And I was just going to add one more that I'm aware of because I recently got a grant through Federal Highway's ATCM TD program, and that was awarded to the Delaware DOT to create an artificial intelligence, just looking at the press release, artificial intelligence transportation management system. So they're basically, I don't want to speak for Delaware DOT, so I don't know a lot about it, but that's one to be aware of and look out for in the future. They've got a lot of data sources in the Delaware DOT, all being fed into their TMC. And so the plan is to use AI to be able to better and more intelligently use the data that they're getting into making real-time decisions in terms of travel information and their traffic management systems. So that's one to be on the lookout for in the future as well.
All right, thanks a lot, panel. I think that concludes the Q&A session. And so I wanted to hand it back to Nilu, but also perhaps show the presenter contact information one more time, if that's possible. Thanks a lot.
Thank you, David. So great presentations from everyone. I hope you found it valuable, just like me. So thanks, David. Thanks, James, and Dan and Joshi for the great presentations. So that concludes today's webinar. Thanks, everyone, for joining us.
Thank you.
Thank you.
Thanks a lot.